Avi Loeb, welcome to the Astroben podcast. How are you?
Thanks for having me. It's a great pleasure.
It's genuinely such a pleasure to meet you. Two of my favorite podcasters are Joe Rogan and Lex Friedman, and I remember both your chats with them early last year. I think I listened to them back to back. It was early January, and at the time I was still in lockdown here in the UK because we had about three or four lockdowns. So it was a good distraction to think about the possibility that we'd been visited by alien life instead of thinking about COVID.
Thank you so much. I had about 1,700 interviews in addition to those two. It was a very hectic time, but I enjoyed every day because I would jog at 5 a.m. in the morning and see the sunrise in the company of ducks, bunnies, wild turkeys, and birds. And that was the perfect type of isolation. And focusing on nature is pretty much what I like to do.
So you had a lot of interviews. So perhaps we should just dive straight in there as to why. So you attracted a lot of media attention for suggesting that an alien spacecraft may have visited our solar system. Um, I'm going to probably pronounce it wrong, but is it a Oumuamua? Is that how you pronounce
Oumuamua.
it?
Yeah.
Oumuamua.
Oumuamua, which means a scout in the Hawaiian language, simply because it was discovered by a telescope in Hawaii, Pan-STARRS, and that telescope was supposed to survey the sky for objects that get close to Earth, and it flagged one such object, and then the astronomers realized that it moves too fast to be bound to the sun, so it was declared as the first interstellar object that came close to Earth and originated outside the solar system. And one expects such an object to be similar to the objects we've seen in the solar system. In other words, it could be an asteroid, a rock, or it could be a comet where there is ice on the surface that evaporates as the object gets close to the sun. But it didn't look like either of these. It looked quite weird, I must say, because as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. That meant that it has a very extreme shape. In fact, the likely shape was that of a flat object, pancake-like, and at the 90% confidence based on the variation of light. And then it was pushed away from the sun by some mysterious force that declined inversely with distance squared, and it had no cometary tail. It was definitely not a comet. And so the question is, what was pushing it? And I thought of the sunlight pushing it. That was the only explanation I could think of. But for that, the object had to be very thin, sort of like a sail. And in fact, 3 years later, the same telescope in Hawaii discovered another object that was pushed away from the sun by radiation pressure and didn't have a cometary tail. And within weeks after that, the astronomers realized that in fact it's a rocket booster that was launched by NASA in 1966, and it's made of stainless steel. That's why it doesn't have a cometary tail, and it has thin walls, and that's why it's pushed by radiation pressure. So here we have it, an artificial object, simply because we know that we launched it, detected by the same telescope in Hawaii. The question is, who produced Oumuamua? Now, the other thing that happened more recently, actually in 2019, together with my student, we found in a catalog that the US government compiled of meteors. These are objects that are not just passing close to Earth, but actually are colliding with Earth. You can think of the Earth as a fishing net that is collecting fish along its path around the sun. And one of these meteors, roughly half a meter in size, identified by the US government sensors, came really fast, 45 kilometers per second, when it was 18.7 kilometers above the ocean surface, and it exploded at that point and released a few percent of the Hiroshima bomb energy, about 100 miles off the coast of Papua New Guinea. So we calculated what its speed was far from the sun, and we realized it was 60 kilometers per second, and that was more than 95% of all the stars in the vicinity of the sun. So it was definitely unbound to the sun. And then when we submitted a paper for publication about this meteor, which was actually the first interstellar object, almost 4 years before Oumuamua, the reviewers of the paper said that they don't believe the US government, the uncertainties in the measurements. And then we had to wait for 3 years until the government released a letter from the US Space Command in March 2022, this year, to NASA, stating that they confirm our conclusion that this meteor came from interstellar space at the 99.999% confidence. And at this point, our paper was accepted for publication. And then we looked back at the catalog and found another meteor. So we have 2 interstellar meteors from the government catalog, CNEOS. The second one was discovered in March 2017, about half a year before Oumuamua. The first one was discovered in January 2014, almost 4 years before Oumuamua. So we have 3 objects, the first 3 objects, and it looks like all 3 of them are weird because the 2 meteors are the toughest in the catalog. The government also released the fireball that resulted from the explosion of these meteors, and we calculated that their material strength for them to remain intact down to the lower atmosphere of the Earth, they had to be tougher than iron, both of them. And the first one was tougher than all other meteors in the catalog. The second one was tougher than all of them except one. And so the chance of drawing these 2 meteors out of the population of space rocks that come from the sun, from the solar system, is 1 in 10,000, a very small probability. So it's clear that these first interstellar meteors, the 2 of them, originate from a source that is very different than a planetary system like the solar system. So here is the puzzle. Why would the first 3 interstellar objects, the first 2 meteors that collided with Earth that were roughly a meter in size, and Oumuamua that was roughly the size of a football field, 200 times bigger, why would all 3 of them, even though they were the first, be so different than rocks that we had seen in the solar system? And there is this lingering possibility that they were, well, at least one or all of them, were artificial in origin. And if so, that indicates that they're just like a plastic bottle that we may find on the beach among all the rocks that we usually see there. And we can find out, by the way, because we're planning an expedition. I just received $1.5 million to support an expedition to Papua New Guinea to scoop the ocean floor, find the fragments from this first interstellar meteor, and figure out the composition of those fragments. If we find that they're made of some alloy that nature doesn't put together, imagine stainless steel, for example, then we can demonstrate that not only it came from outside the solar system, because the composition is different than anything we had found from asteroids or other types of meteors. Not only that, but it's also artificial in origin. And of course, that would have dramatic implications.
Of course. It's so mind-boggling. I mean, what do you think it is? You've explained that it's not a comet, it's not an asteroid. There are certain there's certain things about it that make you question that it's come from somewhere else. So what do you think it is? What's your strongest prediction? Do you think it's an alien civilization?
It's a possibility, simply because the object discovered in 2020, which is called 2020 SO, behaved in ways similar to Oumuamua, and it was artificial because we produced it. So it's possible, and the question is, what was it doing in our neighborhood? And one possibility is that it's space trash, like the outer layer of a bigger spacecraft, or that it is a pamphlet, some letter in our mailbox that it would be tragic for us to ignore it, because it's just like finding a love letter in the attic addressed to someone who never opened it. So I have no idea what it is, but it looks very different than rocks. And that, of course, should alert us to find more of the same, and perhaps also figure out the nature of this first interstellar meteor. So all I'm advocating is that we use the scientific method and collect more data. For example, if we had a high-resolution image of Oumuamua, we could have figured out whether there are bolts or screws on the surface of the object that would indicate that it's artificial, whether there is a label saying made on exoplanet Y. There are ways to tell the difference between an object that was made artificially and the kind of suggestions that mainstream astronomers made. So the response of the mainstream community was to suggest that Oumuamua indeed is an object of a type that we've never seen before, but maybe it's made of pure hydrogen, a hydrogen iceberg, and then we can't see the evaporation of it because hydrogen is transparent. Or maybe it's made of pure nitrogen, and then we can't see it. Or maybe it's a dust bunny, a collection of dust particles, very loosely bound, 100 times less dense than air, so that it's like a feather. It's being pushed by reflecting sunlight. We've never seen anything like that, and we don't know whether nature produces such things. But with a high-resolution image, we can definitely tell. And my point is that we should attempt to collect that data, because if you don't expect the unexpected, you will never discover it. If you don't allow yourself to venture into the unknown, if you just assume that it's a rock, you call it a comet even though it was not a comet, then you are basically betraying the scientific inquiry, which is supposed to allow us to gain new knowledge. And the only way to do that is by getting more data. I would be delighted to have a photo album of Oumuamua instead of writing my book. A picture is worth 1,000 words, in my case, 66,000 words, and it would save me the time if we had just a photo album of this object.
Mm. So you mentioned, you must forgive me because I'm not a physicist, so I'm just trying to get my head around the whole concept. You said that it traveled faster than gravity's strength from the sun. So in essence, it sort of pushed away a rocket effect. Is that because it could be made of something that's so dense or so light that it wasn't captured by the sun's gravity? How did it pass straight through? That doesn't really make much sense to me.
Well, it came from outside the solar system. In fact, it was very unusual in the sense that it came from the so-called local standard of rest, which is the frame of reference that you get to when you average over the motions of all the stars in the vicinity of the sun. And this object was at rest in that local parking lot, you might think of it, sort of like a buoy that is sitting at rest on the surface of the ocean. And then the sun moves relative to that frame. So the sun bumped into it, just like a giant ship bumping into a buoy, and gave it a kick. So the relative motion between Oumuamua and the sun was just because the sun is moving relative to the local standard of rest. And that was a relatively high speed. So when we saw the object, it was clearly unbound to the sun because the sun's gravity obviously did not keep it bound to start with. It was outside the solar system and the sun moved and collided with it. That's the way to think about it. And the other objects that I mentioned, the meteors, for example, they were not in the local standard of rest. They were moving very fast relative to that frame, faster than most stars, actually. So they are from a different frame. They came from somewhere else. But the point of the matter is that all of these interstellar objects were moving fast enough not to be bound to the sun. So just imagine a rocket. If we launch it fast enough, it escapes the gravitational pull of the Earth, and then it goes into space. And so basically you can tell whether an object is bound to Earth or the sun based on how fast it's moving.
So the US government, I think it was last year, they sort of leaked to the press that they've recovered objects that are not from this Earth. It was a very sort of cleverly worded. It seems like it was teeing the public up for the possibility of UFOs. Was that connected at all, or did it just so happen to be around the same sort of time as Oumuamua?
Well, no, it's a coincidence because these are objects that the claim is that they move in the Earth's atmosphere in ways that cannot be explained uh, by objects manufactured by humans. So they do not belong to another nation. And moreover, they do not appear to be natural to the government. So the government is puzzled, the US government, by the data. And the Director of National Intelligence, Avril Haines, delivered a report on June 25th, 2021, to the US Congress. And as a result of that, Congress authorized the establishment of a new office in government that will assemble all the data that comes from all branches of government, including the intelligence agencies and military, the Department of Defense, and see what it amounts to and try to explain it and perhaps collect more data. And in fact, I met with the head of that office just last week. And it's a very interesting question as to what is the nature of those unexplained objects. And that's why I established the Galileo Project about a year ago. There were a few multi-billionaires who visited the porch of my home. They were inspired by my book, Extraterrestrial, and they gave me a few $1 million to my research account at Harvard University. And that allowed me to establish the Galileo Project, which, among many things, aims to bring clarity as to the nature of these unidentified aerial phenomena in the Earth's atmosphere. And there are other tasks that the Galileo Project is engaged in. One is to date the next Oumuamua, come close to it, take a close-up photograph. And for that, we will use a dating app called the Vera Rubin Observatory, which is a telescope in Chile that will start operations in 2023 and will have much better sensitivity than the telescope in Hawaii, Pan-STARRS, that discovered Oumuamua. So there is a chance that we will see other objects like Oumuamua, and I call it a dating app because most of the time we might swipe to the left, but if there is an interesting, unusual object, we might decide to send a space mission that will come close to it and take a photograph. And the Galileo Project is trying to design such a mission. And the third branch of the Galileo Project is involved with the expedition to Papua New Guinea, trying to collect the fragments of the first interstellar meteor. So we are addressing a variety of objects that are being discussed as if they came from outside of this Earth and perhaps outside the solar system, and trying to see, I call it interstellar space archeology, trying to figure out if we see any relics from civilizations that might not be around anymore. The senders may not be around, and those, if it's functional equipment, it may have artificial intelligence. It doesn't need to wait for guidance from the senders. And so let's just see what's around us. I don't think it's a philosophical question. It's a question that we can address using the scientific method by building instruments and putting them to look at the sky. And we already assembled a suite of instruments that the Galileo Project is now testing. And the data that will come from it, basically a movie of the sky in the infrared, the radio, the optical bands, and in audio. And the data will be analyzed by artificial intelligence systems, and we shall see what we get.
Wow. So where would you focus on first with the telescope? Would you focus on where Oumuamua came from? That would be the sort of logical first place to look, or do you have another destination in sight?
No, so the suite of instruments that we plan to use will target the unidentified aerial phenomena in the Earth's atmosphere. And what we want to figure out is whether we can explain everything that we see as either human-made, like drones, airplanes, satellites, or as natural phenomena like thunderstorms, birds, bugs. So, and the question is there anything else, okay, that perhaps represents technologies that are not from this Earth? Okay, so that's the question we are trying to first, just by seeing if there is anything unfamiliar in the sky that behaves in ways that we cannot easily explain. And that's with respect to these unidentified aerial phenomena that the government talks about. And we want to help the government figure out what these might be. Then with respect to objects like Oumuamua, we want to figure out their nature. Are they natural or artificial in origin? And for that, we will use telescopes or design a space mission that will come close to one of them. And then with meteors that came from outside the solar system, the goal is to go to the sites where they landed and, scoop the fragments and figure out their composition. That will be the first time that humanity puts its hands on the material that makes an object that came from outside the solar system.
So interesting. Well, we've just heard today that NASA's DART mission successfully changed the asteroid's trajectory and orbit. So if another asteroid is heading our way and tries to take us out like the dinosaurs, we now have a planetary defense system. Or do we? Does that technology enough to protect us? If another Oumuamua was heading straight for us, would that work?
Well, there are two lessons we can learn from the story about the dinosaurs. One is they were very proud of themselves, the dinosaurs, because they dominated their environment. They were very massive. They ate grass. They're very happy. And the only thing is they were not smart enough to look at the sky. And we humans developed telescopes that can warn us. And by the way, that was the reason that the Pan-STARRS telescope and the Vera Rubin Observatory were constructed. It's a result of a task that the US Congress gave NASA to identify 90% of all objects bigger than 140 meters, the size of a football field. That task was given in 2005, and we are still working towards it. But in the process of identifying near-Earth objects, we do find these interstellar objects. So that's a benefit of that search. But the existential risk from a big rock is out there. And what can we do about it? Well, one thing, obviously, we can send a spacecraft that will collide with it, just like DART demonstrated. That's sort of a brute force approach. There are other ideas. For example, you can send a spacecraft that will spray paint one side of the object. And by doing so, it will reflect sunlight differently or evaporate differently. And that would lead for a small nudge to the trajectory of the object. So if you catch it far enough from Earth, you just need to give it a very small nudge and it will miss the Earth. So there are more elegant ways. You can also evaporate part of it by shining a laser on it, and by that deflect it sideways. And you don't need to do a lot if you catch it very far away. So there are different ways to do it. One of them was demonstrated by DART, but it's by no means the best way. It really depends on the object that one wants to deflect, how big it is, because, in terms of spacecraft, we have a limit to how big we can make them. So if this dangerous rock is too big, we cannot deflect it by colliding with it very easily. But we could evaporate perhaps part of it, or we can paint it, or we can do something else to it. The point is we need to catch it early enough so that we have enough time to respond to it. And I think by now we already know that there is nothing in the coming centuries that would risk our existence. The more immediate risks come from human activities like climate change, escape of some very deadly virus from a laboratory, things like that, or a nuclear war.
Where is Oumuamua now? Because I was reading about a team of scientists that want to build a spacecraft to chase it down. Project Lyra. I don't know if you've heard of it. And is that
Yeah.
possible? And even if it was possible, do you think anyone should try it, given that it could be extraterrestrial?
No, I think it makes very little sense for a variety of reasons. First, the object by now is extremely faint. It's more than 1 million times fainter than it was close to Earth because the flux, the brightness of the object declines inversely with distance to the fourth power as it goes away from the sun. So by now it's extremely faint, and if you wanted to chase it, you would need to equip any such spacecraft with a telescope that would detect Oumuamua, and that would make the spacecraft very heavy. We just don't have its trajectory pinned down to a sufficiently precise level for us to know where to go. So we need to see it. And the problem with that is also that there might be many more objects out there, that reflect roughly the same amount of sunlight. So how would you be able to tell easily? You have to see how fast it's moving, and it's a very complicated task. I think the issue of identifying it, knowing exactly where it is, and then chasing it also is very challenging, because none of our spacecraft moves fast enough to catch up with Oumuamua. We need some gravity assist or some new propulsion method. But the point is, it's just like obsessing with your first date. And very often, as people may know from dating, that's not the right approach. If your first date is gone, then it might be better to seek someone else that resembles your first date, that will come along. And with the Vera Rubin Observatory, we can find another one. If Oumuamua was a one member of a population of objects on random trajectories, then the Vera Rubin Observatory will find one every few months. So that's why I called it a dating app, because we can just go on these many dates instead of obsessing with our first date.
I love that analogy. We're actually coming to the end, which is a shame. The half hour's whizzed by. So many things I could ask you about, but I was wondering, you've had such a illustrious career to date, and what discoveries in physics and science do you hope to live long enough to witness?
Well, the first one is I very much hope that we will find evidence for a gadget that was manufactured by an extraterrestrial technological civilization. And the reason I hope that is, first of all, that's the remaining belief we have that gives us a sense of being special and unique. We used to think that we are the center of the universe, and that turned out to be wrong. And moreover, we realized the universe existed for 13.8 billion years before we came to exist. So clearly the cosmic play is not about us. We are not at the center of the stage, and the play has been going on for a long time. So, we are not primary characters in that play. But we still tend to think that we are the only sentient beings in the universe. And that illusion will go away. I'm quite confident in the coming decades. First of all, our own artificial intelligence systems will outsmart us. In any Turing test that we will make by the end of this century, I'm quite confident that there will be an AI system that will be indistinguishable or smarter than a person. And as a result, sentience will not be unique to humans. We would have created a machine that is in our image. Just like in the Old Testament, it says that God created humans in its image. And here I say that humans created AI systems in their image. And once the AI systems talk to each other and start to evolve in an uncontrolled way, where we are not capping their ability to learn, then they might outsmart us, and we will reach a point that we are definitely not the smartest in our neighborhood. And in addition to that, I believe that around this century we will find evidence for a smarter kid in our cosmic neighborhood by finding gadgets, not by looking for radio signals. You have to understand, radio signals escape the Milky Way galaxy. They move at the speed of light. So if they were sent 1 billion years ago, they are now 1 billion light years away. and we have no chance of seeing them. We can see only those civilizations that are transmitting at the time that we are observing. But in the case of spacecraft that are launched by chemical propulsion, they will be bound to the Milky Way galaxy forever because their speed is less than the escape speed from the Milky Way. So you can think of our galaxy as a basket that collects all the equipment that was launched by chemical propulsion and over the past 10 billion years. And we have a chance of seeing evidence for civilizations that are not around anymore this way by doing space archaeology. And I think that would reveal that we are not the only ones and that there were smarter civilizations before us. Because what's the chance that Albert Einstein was the smartest scientist who ever lived since the Big Bang? Quite small. And I think we could learn about new technologies. We could learn about aspects of physics that we currently don't understand by examining gadgets that originated from a civilization that had a science and technology development of more than a century. That's pretty much what we had, 1 century of modern science and technology. Just think about what we could accomplish in 1,000 years, in 1,000,000 years, and they may represent our future. So there is a lot for us to learn. And I have no problem learning from a smarter kid on the block. I mean, it might appear as if we are cheating in an exam, that we are supposed to answer the questions ourselves, but if it can save us 1,000,000 years, so be it.
So fascinating. I guess it's, having listened to you a few times, it's, you seem to, you've used the phrase before that physics is a dialogue with nature. And I think that's quite a sort of humble way of looking at the universe. We don't have all the answers and we have to challenge our assumptions and assume that everything we know about the universe is wrong, because we're always going to get a level deeper.
Yeah, we should allow nature to educate us. And the way it does it is by experimentation, by collecting evidence. It's not a belief system where like in spirituality, an individual is convinced by having some experience. In science, it's knowledge that can be shared by all scientists, and it's collected by instruments. And that's the way evidence is brought into science. And that's the path that we should pursue. I mean, the biggest limitation is the blinders we very often put, saying everything we see in the sky must be a rock. That's a blinder. Why not examine it openly and say, okay, well, it looks very strange. Let's collect more data.
Avi Loeb, thank you very much for coming on the Astroben podcast. Thank you.
Thanks for having me.